hot doon. Ita. Unsa man yung message dire? Yes. So, let's start.
Now, based firewalls. All modern Linux kernels use the net filter system as a firewall solution for packet filtering. The kernel's packet filtering system, net filter, needs a user interface. IP tables is one such interface. The output of IP tables is what you see here in front of you. When a packet reaches a device, it is handed off to the net filter subsystem for acceptance, manipulation, or rejection based on the rules supplied to it via IP tables. Thus, IP tables is all you need to manage your firewall if you're familiar with IP tables. But many front ends are available to simplify the use of IP tables, which is a command line utility. With NetFilter and IP tables, you can configure the firewall to allow certain types of network traffic to pass into and out of the system. For instance, HTTPS traffic out. This is done by opening and closing TCP and UDP ports in the firewall. Additionally, it can be configured to allow or restrict access to specific IP addresses or IP ranges. So the rules work on the port, protocol, and IP level, and the network and transport layer. IP tables is the database of firewall rules. The traditional interface for configuring IP tables is the command line interface. IP tables is on almost all Linux distributions unless it's some sort of super small additional distribution. Here I'm on Kali and I'm going to demonstrate the command line of IP tables. That shows that we have IP tables installed. The -L is showing the list of chains and rules for IP tables. If IP tables is not installed, then you can install it in the usual way. Like that, or with whatever package manager you use on the distribution that you've got. Let's go through the basics of IP tables. So there are 3 default chains, and you can actually see them here in front of you with this IP tables -L command. And you can see that we have the input chain, we have the forward chain, and we have the output chain. If we start with input, input controls inbound connections, as the name suggests. So for example, if we wanted people to be able to ping this laptop, we would enable a input rule to enable ping, or if we wanted somebody to be able to connect to this laptop for file shares, we would enable an input rule for those ports that enable those file sharing. Then you have the forward chain. This is also used for inbound connections and controlling inbound connections, but for those that are destined to be forwarded on to another device and not this device. So think of it as a chain for like a router that forwards traffic. Unless your device is a router, or it's doing NAT or something special like SSL stripping, you won't use this forward chain on a laptop or a desktop. And then there's the output chain, which controls outbound connections. So for example, if you wanted this laptop to be able to surf the web, you might enable port 80 and port 443 and UDP port 53 for DNS. Chains have default behavior called default policies. As you can see here, we've got the input chain has a default policy of drop. So that means that when none of the existing rules apply, the connection will be dropped. and these here are the existing rules. iptable starts at the top of its list of rules and goes through each rule until it finds one that matches. If one does not match, it applies the default policy, which in this case is drop. In this case for forward is drop, and for this case for output is drop. And this is just what I've set them to. They can actually be set to 3 different options, and those are accept, which is allow connections to come through. You've got drop, which is this, which is to drop the connection and send no response back to the source. So they would get a request timed out on a ping, for example. And then you can reject, and reject means don't allow the connection and send back a response to inform the source that it has been rejected. And if you were to do a ping, for example, you would get destination port unreachable. So I'm going to delete these rules now using the flush command. So that will have deleted the rules. So we can check the rules again with iptables minus capital L. And we can see that all the rules have been deleted. We want to set a default policy for each of the 3 chains, and we do that like this. I'm going to copy and paste these in to make it quicker for me. So if I wanted to change it to drop, actually it is drop, but if I wanted to set it to drop, I would do this for input. If I wanted to change it to accept, I would change it to that for input. Let's have a look. There we can see it's changed to accept. If I want to change it output to accept, I need to spell it right. And there we can see that input and output are on accept. But for this demonstration, what I'm going to do is I'm going to set up some rules as if this is a laptop that I want to lock down so that all it can do is browse the web. So in order to do that, I want to set drop as the default policy for input, forward, and output. So those will be the required commands for each of the chains. And we can see now they're all set to drop. So the first rule I'm going to put in is iptables minus capital A. Minus capital A is append. We're going to put it on the input chain with minus I. LO minus I is the interface. LO is the local interface. And then minus J is the jump switch. So that will jump to the target action for packets matching that rule, and that is to accept. So what this rule will do is this rule will allow all incoming packets destined for the localhost interface to be accepted. This is generally required as many software applications expect to be able to communicate with the local adapter. So it's sometimes a useful rule to always have. And there we can see it's added. If I want to see more information, I can go for a verbose listing of the rules, which with a -V. And we can see some extra information here. We can see the packets that have gone through it and the number of bytes. We can also add -- line number, and that's going to give us numbers for each of the rules. So you can see here that's rule number 1. We can add a little more, -N, and this will show us the numbers instead of the names. This is the next rule that I'm going to add, iptables minus capital A. Again, that's A for append. It's appending it to the input chain Then we've got this minus M state, minus state related, comma established, minus J accepted. The minus M loads a module called state. The state module is able to examine the state of a packet and determine if it is new, established, or related. New refers to incoming packets that are new incoming connections that weren't initiated by the host system. Established, which we have here, and related, which we have here as well, refers to incoming packets that are part of an already established connection or related to an already established connection. So this is enabling dynamic packet filtering, which we talked about already. If we just set up a rule to surf the web on port 80, because we've set this rule here, we don't need to have a rule allowing the traffic to come back from the web server. Because we have established the connection, this rule knows the state and allows the web server to communicate back. And there we can see the rule there, rule 2. And here's the next rule, which is very similar to the one we've previously done, but for the output chain, this will allow all outgoing packets destined for the local host interface to be accepted. Again, that's because some software applications expect to be able to communicate with the local host adapter. And there's that one. And this is our second dynamic packet filtering rule, but this time for outbound traffic to be able to come back and understand the state that a connection has already been established or is related. And there you see it, number 2 in the output chain. So currently all we have here is the ability for connections to communicate with the local host and dynamic packet filtering to work both outbound and inbound. Now we need to add the rules. So if we want to surf the web, we're going to need port 53 UDP so we can do DNS queries, which we do with this command here. We have the -O, which is another switch for establishing the interface. We've got the protocol, which is UDP. We've got the module, we've got the destination port of 53, and we've got the jump switch to accept. And we can see that here. Number 3, if we get rid of the -N, so I'll change that to show as domain as opposed to 53. Now we're going to add port 80, the main HTTP port, with mostly the same settings as we did with port 53 for DNS, but we're changing it to TCP, and we're also setting the state as new. We can see that here, rule 4. And our final rule here, port 443, so we can do HTTPS. There it is at the bottom, rule 5. So we can see here, from any source to any destination, allow UDP on port 53. From any source to any destination, allow TCP on port 80. And same again, from any source to any destination, allow TCP on port 443. And we have the other rules here and here to maintain state. So let's test this out with wget. And there you go. So DNS has worked and port 80 has worked. And port 443 has worked. If you want to see the commands that were entered to create the rules, you can use the -S switch, which is quite useful. And you can see there, these are the rules that I put in. Quite a useful command. On Kali and Debian, that's how you would save these rules, using iptables-save. Now maybe we want to delete some of these rules. If we list the chains and the rules with the -- line number, we can then use the line number and the chain to delete that particular rule. So there we've got iptables-D, which is delete from the output chain rule 5. Rule 5 being here, it's going to delete HTTPS port 443. That's gone. And we list it again, we can see we've only got the 4 rules. Let's try doing a wget to HTTPS, which should not work. And there we can see it is not able to work as would be expected. And let's try it on port 80, which will work. And there you see that works. If you want to remove all your rules and start again, I would suggest starting by changing your chains to accept first, which you can do in the way I've already shown you. So I would change them to accept. So you can see the chains have all changed to accept now. And then I would suggest using these commands here. If you're using NAT or the mangle tables, but if you're not, you can throw them in anyway just to make sure it's cleared out. The -F is the flush command, which is essentially deleting all, and the -X will delete any non-default chains. So this will have left us with input, forward, and output chains, but with no rules, as we can see here. So that's effectively the same as having the firewall switched off. So let me add a rule again, the port 80 rule. And there we can see the rule there. Now this is for IPv4 only. If you type IP6 tables -L, you'll see that IPv6 has a completely separate set of rules. These will need to be configured separately. If you wish to disable IPv6, you can do it with these commands, which gives a default drop to inbound, outbound, and forwarding traffic. Most people will not be using IPv6. If you want to know what sort of rules that you should establish on a laptop or a desktop, if you want full protection using IP tables, then check out these rules and settings that are here. Plus, there are also some useful scripts that will automate adding the rules. If you look through the script, it'll make sense to you now that we've gone through IP tables, some of the changes that are in here. So for example, you can see here, it's allowing outbound port 80 HTTP connections as an example. Within this script, which you can download and use, it enables or disables a few kernel features to harden up the firewall. It makes the default policy to drop instead of accept, like I showed you in my example. It allows all packets from related and established connections, again, which I showed you. It always allows loopback devices, again, which I showed you. And then above what I've showed you, it starts to add things like it drops all IANA reserved IP addresses, which would help prevent DDoS attacks. It allows Skype incoming, DHCP outgoing, DNS outgoing, HTTPS outgoing, NTP outgoing, ping outgoing, SMTP outgoing, and SSH outgoing. Obviously, you can enable or disable whatever it is that you want. That's just what happens to come with it. And it also drops all IPv6 traffic. If you're using other services, Tor, VPNs, obviously you're going to need to enable those. based on the ports that they use. Just copy one of the rules and change the ports, and you should be good to go. Other than this link here, there's also this link here, which has got more information about that script that I've just told you about. And if you're looking for the definitive guide on IP tables, it is probably this one here, which covers pretty much everything on IP tables. So check out that link as well.
Okay.